Hello and welcome to this video where we're going to be looking at similar volumes. Here we have three cuboids which are all mathematically similar. You can tell that because to get from the first cuboid to the second, all of the lengths have doubled, so scale factor 2 on the lengths. To get from the first to the third, all of the lengths have tripled, so a scale factor 3 on the length. So here we have a scale factor 2 on lengths, and here we have a scale factor 3 on lengths. Now, what about the volumes? Well, the first one is 5 times 2 times 3, which is 30 centimeters cubed. The second one would be 10 times 4 times 6, which is 240 centimeters cubed. And the final one would be 15 times 6 times 9, and this would come out as 810 centimeters cubed. So if the scale factors for the lengths were 2 and 3, what about the volumes? Well, the scale factor from the first to the second in terms of volume is times by 8, and to get from the first to the third is times by 27. So what's going on here? If we double the lengths or triple the lengths, the volumes go up by factor 8 and factor 27. And if we look at that in terms of a table, so we have the length scale factor of 2, the length scale factor of 3. What was the volume scale factor? So when I doubled the lengths, I increased the volume by scale factor 8, and when I tripled the lengths, I increased by 27. Now it should be clear that 2 to the power 3 gives you 8, and 3 to the power 3 gives you 27. So to get the volume scale factor, you cube the length scale factor. So if I made the length scale factor 4 and times all of the lengths by 4, I would do 4 cubed, which gives 64. So the volume would be 64 times greater. Let's see how we can use this in a question. So here we have an example. We've got two shapes A and B which are similar, and the volume of the first one we're told is 30 centimeters cubed. Calculate the volume of the second one. So much like similar areas or similar triangles, I start by writing x over. So x is going to be my volume of the second shape, so I would divide that by the volume of the first shape. And then that here is my volume scale factor. My length scale factor would be 6 over 2, like so, and making sure that I am consistent and have the larger on the top, because over here I had the larger volume on the top. Now if this is a volume scale factor and this is a length scale factor, then I need to put some cubes on my length scale factor to make this question work. Then just like before, I rearrange, so I have 6 cubed times 30 divided by 2 cubed, so x would give me 810 centimeters cubed. Here's a practice question for you to try on similar volumes. Press pause, have a go at this one, and then press play and I'll tell you what the answer was. Okay, so for this one, first of all, we write x over 24, so this is our volume scale factor, and then we write 6 over 3, making sure that our larger amounts are on the top. Then I cube my length scale factor and then rearrange, so we've got 6 cubed times 24 divided by 3 cubed. Then if we type this onto a calculator, we would end up with a final volume of 192 centimeters cubed for the volume. Okay, here's a second example then. So things are slightly different this time. Now we're told some information about the volume, so we need to calculate a length x. So just like before, we're going to set up our fractions. So x is corresponding to this 15. So I have the small length over the big length, so I want the small volume, 125, over the bigger volume. Now this time, rather than putting the cubed over on this side, because this is my volume scale factor, I put the cubed on this side, because this is my length scale factor. So when we come to rearrange, we would have x cubed equals 125 times 15 cubed divided by 1000. And then x would equal the cube root of 125 times 15 cubed divided by 1000. So you would simply type this into a calculator and you would end up with a length of 7.5 centimeters. So the way this differs from the previous one is, rather than finding out a volume, you're finding out a length, so the cubed has to go onto the x rather than onto the other numbers. So x equals 7.5, and that looks reasonable because this is a larger length, 15, and this would be a smaller length, 7.5. Practice question for you then to try. It's very similar to the last one. Press pause and have a go, and then press play and I'll tell you what the answer was. Okay, here's the answer then. So we have x over 4 equals, so that's our big length divided by our small length. So we want our big volume, 500, divided by our small volume, 27. The cubes go on the length scale factors, and then we rearrange. X cubed equals 500 multiplied by 4 cubed divided by 27. X would equal the cube root of 500 multiplied by 4 cubed divided by 27. And then if I type that onto a calculator, I would end up with 10.6, and that is rounded off to 3 significant figures, so 10.6 centimeters. Example 3 then. So this question is probably the hardest type you can get. You haven't been given any lengths at all, but you've been given 2 surface areas and 1 volume, and you're asked to calculate the other volume. So our volume scale factor, x divided by 160. So we have the volume of B, the larger volume, divided by the smaller volume, the volume of A. Then we do the same for surface area, 81 over 36. Now, at this point things become tricky. Normally we'd be looking for our length scale factor so that we can either cube it or square it or something, but we don't. We only have a volume scale factor here and an area scale factor here. But there is a nice trick you can do. If you square root your area scale factor, then this would be the same as a length scale factor. So if this here is a volume scale factor, this is now a length scale factor, then I just need to cube both of these. Then I've set up my question as before. So the very tricky bit there was we have 2 scale factors that don't have a length in them. We have the volume scale factor here, the area scale factor here. If we square root the area scale factor, that gives us a length scale factor. Then if we cube that, we're where we were before. So what I would probably do at this point is have x over 160, then just work these out. Well, the square root of 81 is 9, and if I cube that, I get 729, and the square root of 36 is 6, and if I cube that I get 216. You may not be able to do this necessarily in your head, you may have to get a calculator to do that for you. So x equals 729 multiplied by 160 and divided by 216, and if you type that into your calculator you will end up with 540 centimeters cubed. At this point it's usually sensible just to check your question. So we had the volume of A was 160, the volume of B we found is 540, and we know that B is bigger, so that does make sense. Here's a question for you to try, which is quite similar to the last one. Press pause, have a go, and then press play and I'll tell you what the answer was. Okay, for this one then, so we have x is the volume of A divided by 150 the volume of B. So we have the large volume divided by the small volume, so we have the large surface area divided by the small surface area. We need to square root the surface areas and cube them. And because 280 square root isn't a nice number, I'm going to let the calculator do all of the work for me. So I'm going to write x equals the square root of 400 cubed, times that by 150, and then divide that by the square root of 280 cubed. Now if you manage to type all of that into your calculator, you should get 256.1, and that will be rounded to 1 decimal place, and the units for volume, centimeters cubed. Well done if you got that. That was a very tricky question. That concludes this video on similar volumes.